going. All right, we're going to do some other coordinate rules today. So far, everything that we've done has either been rigid transformations, isometries that produce congruent figures. Those are our translations, reflections, and rotations. And then we just got through a 3-day marathon of dilations where we produced similar figures that had all the same angles as our original figures, but whose sides were scalar multiples of our pre-image sides. Okay, so different side lengths, but same angles. Today, we're going to really distort our figures by stretching them. So they're not going to be congruent. They're not even going to be similar. They're going to be just straight up weird. It's going to be great. All right. So not all of our transformations will produce congruent or even similar figures. Vertical stretches and compressions have scale factors, but they are only applied in one direction, like the band. Okay, we'll use this coordinate rule where we're going to keep the same x, but we're going to multiply our y by 3. Okay, so only our y is getting stretched. We are doing a vertical stretch on triangle cat. I named almost all of my triangles cat because I like just got that much closer to being the crazy cat lady, guys. All right, our k is 3. So our vertices for cat, what's our vertex for cat or coordinates for C? 2, 2? Okay, what about A? T? Is that -3? Okay, so when we do our stretch, we're going to keep all of the x's the same. So the 2 stays a 2, the -3 stays a -3, -1 stays -1. And then all of our y values are going to be stretched by a factor of 3. So 3 times 2 is 6. 3 times 0, still 0. So just like when our point is on the line of reflection, it doesn't change spots, it maps onto itself. Just like when our point is the center of rotation, it stays where it is. Okay? If we have a point that is on our axis when we're stretching, then it doesn't get stretched. Not if it was on this axis, but if it's on the x, because we're stretching away from the x-axis right now. Okay. -3 times 3 is -9. So now we're going to plot our cute little points. A prime maps onto A. C prime is up here. T prime is down here. Super weird looking. Okay. Obviously, this is not congruent or even similar. It got stretched away from the x-axis. So, what do you notice stayed the same, though? What's the only thing that stayed the same? Well, yeah, okay. But did the figure get any wider or narrower? You see that it's like the same width? Okay. So that will be when we stretch the x's and not the y's. So a vertical stretch is only stretching in the y direction, so our figures will have the same width. Okay? They'll just be all distorted everywhere else. All right. let's try this one. We are going to write a coordinate rule that will horizontally compress parallelogram dogs by a factor of 1/3. So we have to write our own rule. So x, y, maps to. Now on this one, we multiplied the y's by 3 to get a vertical stretch. What do you think we would have to do to change the x's only? Yeah, we just use a 1/3, but do we do it to the x's or the y's if we want to compress horizontally? Yeah, the x's. So we are going to multiply the x coordinates by 1/3 and leave the y's unchanged. So when you were stretching parabolas and linear functions and exponential functions in Algebra 1 last year, you were not stretching and compressing horizontally, everything was vertical. Okay? It was always getting farther away from the x-axis and not the y-axis. All right, that's our coordinate rule. Now we've got to perform our horizontal compression. So let's get our ordered pairs. D, O, G, and S. Will you help me out? It's really hard for me to see when I'm this close to the board. What's the ordered pair? Is it 5 or 6? 6, 2? 6, 2? 0, 4. Negative 9, 0. Is it negative 9? Yep, negative 9, 0. And S, negative 3, negative 2. Okay. So, D prime, O prime, G prime, S prime. We are going to keep the same y value. So 2, 4, 0, and negative 2 should be unchanged. So now we just need to know, like, what's 1/3 of 6? 2. What about 1/3 of 0? Oh, they were nice to us on that one. What 1/3 of negative 9? Negative 3. And 1/3 of negative 3. Yeah. Okay, we can plot our points. So D prime is at 2, 2. O prime maps onto O. G prime, negative 3, 0. Ooh, guess who's not really left-handed? And S prime, right there. So if I look at taking the length from 0 to G, and I chop it into thirds, you see that I've only gone 1/3 of that distance. Okay? If I wanted to be very evil and give you a scale factor of 2/3, you see that you would put G prime here instead. It'd be like 2/3 of the way instead of 1/3 of the way. That's the difference between 2/3 and 1/3. Okay. All right. Well, no one's that evil today, so we'll just keep going. Connect your vertices. And obviously, these are not congruent figures. I still have a parallelogram, but none of my sides are parallel to their corresponding sides. It's all distorted. Any questions? Is that the end of that page? All right, so you get the basic idea. Now we're going to identify some stretches and compressions. So we're going to write two rules, one for mapping XYZ, the triangle to triangle ABC, and then one for going back. So one example, we're going to sort of get two birds with one rock. Okay? All right, so first we're going triangle XYZ to triangle ABC. Are we stretching or compressing? Okay, horizontally or vertically? Good. So, X, Y. It sounds like we're going to keep all of the Y's the same, so that part is easy. I just put a Y. I just have to figure out what's happened to the X's. Okay, so if I make this my 1, and I copy it here, I have another 1, which makes a 2. So I agree. So 2x. Now, let's say that triangle ABC was the pre-image, and we want to compress to get triangle XYZ. What would I do? Yeah. So sometimes these fractions confuse kids, but they shouldn't. Because if you can figure out that this one is 2, but you want to go the other direction, just flip the 2 upside down and make it 1/2. You see what I'm saying? It's just the reciprocal. Okay, so don't let that confuse you. All right, let's try this one. This one's huge. Who made this? Okay, so this time we're going from XYZ to ABC. Yep. So this side is my vertical compression. Go ahead and write a coordinate rule. And this side would be the opposite, a vertical stretch. Okay, what did you guys say for the vertical compression? X, Y, maps to? Okay, good, 1/3. Do we need to talk about how we got the 1/3? Okay, so I count from my x-axis. So here I have, like, this is my 1. Even though it's 2, we can call this, well, we can call it 2 if you want. You see how here I have like 1, 2, and then another 1. So I know that there's a 3. Okay, so if I was getting stretched, I'd be multiplying by 3. But if I'm thinking about compressing, it has to be 1/3. Does that help? Okay. All right, well, I kind of gave this one away, but we can still write it. X, Y, maps to 21. What I didn't write down on these two, it didn't tell me to, but I probably should write it down if this is going to be like my textbook. This was a horizontal stretch. And this was a horizontal compression. Okay, so notice on the horizontal ones, are they changing height? They're just getting wider and narrower, okay? On the vertical stretches, they're keeping the same width, and they're just getting stretched vertically, okay? All right. Using your vast geometric experience, what do you think, we're just going to predict before we try it, what do you think is going to happen if we double the x and we subtract 3 from the y's? What do you think is going to happen? Okay, it's going to get long. Is it going to stay in the same spot? Yeah, so it's going to stretch horizontally, and it's also going to translate down, so it'll be both. Okay, let's write down our coordinates. So we set, well, okay, it says predict, let's write it down. So stretch horizontally by how much? By 2, and translate down 3 units. Okay, fingers crossed we get it right. Okay, W, X, Y, and Z. Okay, what are the coordinates for W? 0, 3? Is that 4, 4 for X? 2, 1? And 2, 0. No, negative 2, 0. Okay. So, 2 different things are happening. The X's are getting doubled. So 0 times 2 is still 0. 4 times 2 is 8. Y times 2 times 2 is 4. Negative 2 times 2 is negative 4. Okay, then the other thing that's happening is subtracting 3 from the y's. Okay, 3 minus 3, 0. 4 minus 3, 1. 1 minus 3 is negative 2. And 0 minus 3 is negative 3. All right, let's do it. Okay, W prime lands on the origin. X prime is at 8, 1. Y prime 4, negative 2. And Z prime negative 4, negative 3. So you can see everything shifted down 3 units, and it got stretched by a factor of 2. So good job. You did it right. Is this the last one? No? Yeah, this is the last one. Okay. We just have to write the coordinate rule that's going to produce this. That's going to map from LMNO to WXYZ. So what do you think? What's happening? First of all, do we have a compression or a stretch? Okay, we're going from this one to that one. Okay, we have a compression. Is it vertical or horizontal? Yeah, it's a vertical compression. Which one? Oh, that's a very good question. L, M, N. This N is an O. Thank you. Okay, do we have anything else weird happening? Okay. So now we just have to put this into a rule. The only thing that we need to be able to do that is to figure out how much it got compressed. Okay, so if I undo the translation and yeah. Okay, let's move W back 6. 1, 2, 3, 4, 5, 6. You guys see that before we did the translation, like we were looking at these two, right? Those are the corresponding vertices. So L is double the height away from the x-axis compared to what W would have been before we translated it. So that's how we know it's 1/2. Everybody see it? Okay, so we were doing x, this is by 1/2. X, y, max 2. Good. X plus 6, 1/2 y. That's it. Perfect. Yeah.